Dear friends, this is my tutorial 18. So in this video you can learn how to calculate the single bond covalent radii for element 1 to 118. So this is very useful to determine the binding strength of metal to support. So this is the paper published in Chemistry European Journal. So molecular single bond covalent radii for element 1 to 118. In this paper they given the periodic table kind of things. So we can use that periodic table to compare our experimentally observed or DFT results. Okay. So this is that periodic table. This is the single bond covalent radii. Actually this. So this is actually in the covalent radii in the unit in PM. Okay, so this is not in the Armstrong, so we can convert into Armstrong by dividing by 100 this value. Okay, if you divide by this value 100 means you will get 0.32 Armstrong. Okay, so now I will tell you how to calculate that binding strength using this value. So this is the first paper I chosen for you to explain to you. Okay, this is published in Dalton Transaction. So in this paper they have reported this one complex. Actually this is the complex. So in the complex they have observed that Mg1Cl1 bond length is around 2.4919. so here you can see the Mg1Cl1 2.4919. So this is the experimental observed bond length. So we have to compare with that single bond covalent radii value. So this is I took from the periodic table. Mg single bond covalent radii is 139 is PM. So for chlorine atom, chlorine we will get is 999. So if you divide by 100 with this two value, you will get 1.39, 0.09 Armstrongs. So if you add this two value, then you will get 2.38. Okay, so now we can compare this experimental value with this one. So if you compare, this value is 2.38, this value is 2.49. this indicate that this is somewhat larger than this one. This indicate that so this MgCl bond is significantly the weak interactions. Okay, there is no covalent interaction in between the Mg1Cl. So okay, likewise you can compare if you are getting any crystals or you are doing DFT studies, so you can compare with this covalent bond radii. So then you can understand the interaction between the two atoms. Okay, this is another paper. So my paper only I studied that phosphorine supported single atom catalyst for CO oxidation. So in this paper also I used this periodic table to calculate the binding strength of metal to substrate. Okay, so this is the system. So actually in DFT calculation observed the ruthenium P1 bond density 2.19, ruthenium P2 2.22 and P2 dash also 2.22. So this is the single bond bond length in Armstrong. So if you see that ruthenium and the covalent radii is 125. So this is a phosphorus atom. So this is the PM value is 111. So if you divide by 100 you will get 1.11. if you add these two things you will get 2.36. okay, so if you compare with this one 2.22 or 2.19, significantly lower than the is very lower than this. Okay, this indicate that this ruthenium and phosphorus interaction is significantly more stronger than the single bond covalent radii. So this is indicating that the strong covalent interaction between these two atoms. Okay, likewise you can if you are doing DFT anything, so just you can compare with this is very useful result. You can add your research. Okay, so thank you. If you like my content, please like and subscribe, comment and share, and also please the bell icon for future update videos. Thank you for watching. Thank you for your time. Enjoy the time.